Hey guys, welcome back to our channel. I have some exciting news to share with you all. Meta recently announced the next version of their cutting-edge auto-regressive transformer model, Llama2. It comes with a range of improvements and advanced features that makes it stand out in the world of open source language models. In this video, we will look at an overview of the Llama2 model, but the main focus of this video will be to fine-tune the Llama2 model for your own use case. We'll be using Google Colab for development, Databricks datasets, as well as Hugging Face APIs for model integration. So let's get started. On this channel, we regularly post content related to artificial intelligence, especially artificial intelligence latest news, deep dive into the research papers, as well as engineering concepts related to fine-tuning and model training. So if you're interested in artificial intelligence and related topics, please do like and subscribe. Also let us know in the comments what kind of use cases you would like to try out with the Llama2 model. Llama2 is the next generation of the open source large language model Llama. It is available for free for research and commercial purposes. You can download the model by clicking on this link here. So you have to fill out the form with your information, and you can also use it for commercial purposes, so it doesn't really matter if you specify that information. So there are two kinds of agreements they want you to read. Generally, this is the community license that was there for Llama 1 model as well. And the second one is the Llama 2 acceptable policy license, which basically says that you cannot use this model for prohibited uses, as well as engage in some illegal activities. So yeah. So inside the model, if you look at it, the model weights and code has been added. You can find also they have added the pre-trained and fine-tuned Llama model. So generally they range from 7 billion to 70 billion parameters. So the higher the number of parameters, the model performs better, in the sense that it will require less number of data set for transfer learning. You can scale the model better, and the only problem with that is that it is bulky, so it will take more space for you. Llama 2 was trained on 40% more data than Llama 1 and has double the context length, so which is quite a lot of data, I would say, and they included I think January to July dataset for this year. So there are different sizes that the model is available on: 7 billion, 13 billion and 70 billion parameters. The model contains 2 trillion tokens. So tokens are basically the smallest unit which can be used for model training. So you can consider it as a word or character, it depends on the model. So Llama 2 was pre-trained on 2 trillion tokens and uses the context length that is larger than Llama 1. And also for helpfulness and safety, they used over 100,000 or 1 million human annotations, which is great. On the benchmark side, Llama 2 outperforms any other open source large language model. So one thing you have to see here is that Llama 2 is not comparable to GPT-4 or Pathways 2 from Google, but it does outperform the other open source models. And that's the key here. So they tried out on different benchmarks like the MMLU benchmarks, Trivia benchmarks. So if you compare, MPT is your, I think it's the Mesos company, it's Moses company from which was acquired by Databricks recently. So it's their model. Falcon Llama 2 is here with the 7 billion parameters. So you can see that the number of parameters increases, the model performance increases as well. If you compare it with the 65 billion, which is the highest Llama 1 parameters or model, Llama 2 exceeds that, and it also quite a lot exceeds Falcon model. Human evaluation is another important data set. HellaSwag is basically to check for the nonsense in the data. So this model quite outperform any other competitive model. Llama 2 was pre-trained on the publicly available open source datasets. The fine-tuned Llama 2 chat model leverages publicly available instruction dataset over 1 million human annotations. This has been supported by a lot of foundations, but the main release has been with Azure and Microsoft. So they especially had a separate presentations with Microsoft CEO. So it's pretty exciting model. Lot of push on this, especially because it is available for commercial usage, which was not the case for Llama 1. So let's try to fine-tune this model. So we'll be using Google Colab, and let's take it from there. To suit every text generation needed and fine-tune these models, we'll be using Qlora. So the main idea behind Qlora is nothing but is to quantize the pre-trained models to reduce memory footprints and computational cost. So what happens, even though the models are pre-trained, they still require a lot of computational resources. So Qlora helps in reducing that. The main idea behind quantization is to reduce the precision of model weights and activations. And generally you try to do that by reducing the floating point numbers to lower representation. So like reducing them from 32-bit to 4-bit. So that's how Qlora allows you to reduce the memory consumption and enable faster computations. Qlora also introduces the concept of something called low-rank adapters. So what that means is like these are small auxiliary neurons or neural networks that are attached to the original model to adapt to a specific downstream task. So when you are fine-tuning a model for your own use case, these small neural networks quite a lot helps. So when you load your Google Colab environment, I think the first step you should do is to change the runtime environment, because this only works in GPUs. So what you can do is you can click on this button and then it can change the runtime for you. And the GPU is not that efficient, but still it works for this case. So this is the first step, because otherwise when you try to run this, it will give you an error. Let's look at the required libraries for this project. So these are some of the libraries required. So we will need Torch, of course, because it's a PyTorch library. Accelerate. So Accelerate is nothing but like it optimizes your inferencing and training. So it's a library from Hugging Face and you can download it from there. Bits and Bytes is the core library for quantization. So something that we talked about a few minutes back is to reduce the memory footprint by using quantization. So this library helps you do that. It is from PyTorch. Transformers are the key backbone of all large language models. So this is the library that you need to install. PEFT is again a floating point computation or computation optimization library from Hugging Face. And these are some of the libraries. So I have already installed these, so I'm not gonna install it again. But it will be a smooth process unless you have not selected the right environment. So you have to make sure that you select the GPU one. These are some of the libraries that we need to import. So some of the functions or libraries, so we just provided here. Now, to use this model, there are two things that are very much important. First is you need to set up your access token. And the second thing is to request a Llama model from Hugging Face. So let's see how we can do that. So if you click on your when you create a Hugging Face account and you click on the profile, you will have an option of access tokens. So you can create your own access token by going here, by creating a new token, and this will be used in the code later. So this is the Hugging Face. You can also, there is another option of using Hugging Face CLI login. So when you use this CLI, you can directly log in and every subsequent cell will be logged in automatically. So these are the two more important ones. So then this is a function to load the model. We will dive deeper into this model a little, or this function a little later. Let's try to first run this. The main idea behind this is just use the pre-trained model. So yeah, we'll come back to this. So let's just run this. And then we are using the data set from Dolly. So Dolly is Dolly is a LLM model from Databricks, and they have an open source data set that you can now download. So we'll just use that data set for now. It's a JSON object. So we will look at the data set as well in a few minutes, but you can download this. Let's just run this first. So now it's downloading that data set. Now let's look at the data. So if you look at the length of the data set, so these are some of the columns that it has. So it has around 15,000 prompts. These are the columns: instruction, context, response, and category. This one was something stupid that I was doing, as I told you, right? I didn't select the right environment and it was giving me like a accelerate not found. So this is not really required. Then you can create so this is a function that allows you to create prompts formats. So there is an intro blurb. So how you describe a task. So this is how this is currently described. So you have an intro blurb, you have an instruction key, so you can have to specify it this way. Then the input key, response key, and the end key. So this is for closing the blurb, and then the response is the response. So this is a simple string manipulation function with some specific format that we have identified. And then let's run this one. So this is the max length function. There is nothing much to explain here. It takes the model config as input, and then it gets the attributes for the model config and the length setting. So these are some of the length settings that we need: sequence length, max position, embeddings, and number of positions. And then it returns the max length. So we just run this. This function is for the pre-processing of the batch. So you specify the batch size, you specify the batch, you specify the tokenizer. So in this case, so batch is the content, and then tokenizer is basically we are trying to tokenize that with the max length. So this is what we are trying to do here. So it returns your tokenizer. So let's run this as well. Now the next step is to pre-process the dataset that we use for the dolly dataset. So we have passed a tokenizer because tokenizer is going to break down the dataset. So we pass the auto tokenizer that we created, and then we have these formats. So like it's gonna map these forms and then apply some kind of manipulation or pre-processing to generate. So let's run this as well. Then it does some kind of manipulations, and then this is a bits and bytes config. So this is very important. So you create a config here that shows load in 4-bit as true. You can specify whether you want it in 4-bit or 8-bit or 16-bit or 32-bit or whatever. And then for this project, we'll be using 4-bit. So this is what it is being specified here. So these are some of the parameters that are required for bits and bytes. And this is the function that will be called later. This is for the pref configuration. So create parameter efficient fine tuning config for your model. So here we are using Qlora. So this is mostly for Qlora. So you're specifying R as 16, which is the dimension of the updated matrix. You have you set the parameters for scaling, the dropout factor, dropout probability for layers, the bias, and the task type. So it's a casual LLM. So this one, did we run? Yeah, we ran it. And then find all linear names. So this is a function that returns you all the linear names for the model. So we'll dive deeper into this when the time comes. For now, we'll just run it. So this basically just prints the trainable parameter. So we just specify the model and it prints all the trainable parameters that were used. This is not required. And this is the main place where the model is called. So once you log into your Hugging Face login credential, once you use the login credential for Hugging Face, it will basically download this model for you. And this is the model we are using. It's a 7 billion parameters model. So this is the lowest grade one. So you can select your 13 billion or 70 billion, but remember 70 billion will not work here. So you need to use the smallest one. You can use 13 billion as well, but let's use the 7 billion one. So this downloaded our model, all the data sets and all the configurations required. So there are two functions it calls here. So let's first try to dive deeper into the load model function. So the load model function, like if you go up, so the load model function, the main things are that you are setting up the number of GPUs and memory. Then you kind of load a pre-trained model. So this is the step that you are trying to do here using the transformer library. So auto model for casual LM from pre-trained, this basically loads a pre-trained model with the model name that you have specified. In this case, it will be LLAMA2, but you can use GPT-3 or whichever you would like to use. It's the same code for both. Then you pass the quantization config. So this is what we talked about, is the bits and bytes configuration that we looked at. And then you can select the device map, the memory, and that info, all that. So overall, the function allows you to easily load a pre-trained casual language model and its corresponding tokenizer, while also enabling quantization and other important use cases. Now let's look at the create BNB configuration function. So this is what for quantization that will be used. So this we already discussed, so we won't dive deeper into this. So these are the two functions that are called, and this is now that your model is initialized and your tokenizer is initialized as well. So yeah, I think let's move on to the next step. So we looked at the model and downloaded and initialized the model. Let's look at the dataset. So as I mentioned earlier, the dataset is a Databricks Dolly dataset. So interesting part about this dataset is that 5,000 Databricks employees in August and in April and March actually worked to generate this dataset. As such, the dataset is like coming from the public web, so it does contain operational and incorrect information. So you have to be careful with that. So we loaded the dataset. So right now I'm just using pre-computed data because it's always takes times to run collab at the same time. So let's assume that I have already run these. If you dive deeper into the data set, we discussed that there are 4 categories. So instruction, context, response, and categories. So I wrote a simple function here to give you more overview, like how the data set looks like. So you can see that there is a context, there is an instruction which is like just a prompt, then context is there, the response, and the category. So it's an open question. You can find other categories as well, like closed questions, open questions, information from Wikipedia, and all that. And the simple example is instruction will be what links Brazil. So it's like a prompt. What links Brazil, Uruguay, Mozambique, and Angola, and all that. Now the next step is we have to pre-process the data set. So instructional fine-tuning is a common technique used to fine-tune a base LLM for specific downstream task. So we need to fine-tune this, and that's why there is this specific function that we have defined, which we talked about earlier. So these are the instructions. So like if you look at this data set, which was a raw data set, we kind of converted it into this format. So instruction is this, response is colonies of Portugal, and all that. So this is the other functions that we talked about. So you can see here the pre-processed dataset function, adding prompt to each sample. So you're adding a prompt here, applying pre-processing to each batch of dataset, and remove the instruction, context, response. So this is just a simple pre-processing that needs to be done based on the data that has been passed. BNB config we already looked at. We also talked about the PEF config, so we won't dive deeper into this. So this one is to get, so we talked about like we need to get the necessary metrics, and this function is basically getting you all that metrics that is required. Now you can print all this. So this we already dived deeper. So this prints all the trainable parameters, helpful function to see how many trainable parameters are in the model. And the next step is the training of these models. So when I run this training, it downloaded the model, the configurations, and everything that we already ran. Now the max configuration that I ran, the function that I used was the get max length. So it gave me like the max length found is 2048, and then I pre-processed the dataset using the map and filter function. The next step is training the model. So apply pre-processing to the model to prepare it by enable gradient checkpointing to reduce memory usage during fine-tuning. So this is a custom function that we created, and you can use this for your own use case. So you specify the custom checkpointing. You can use the prepare model for k-bit training method from PEFT. So PEFT we talked about for fine-tuning, and this is the library from Hugging Face. So this function that we talked about to get all the LoRa module names that we are providing here. Then you provide the pref configuration for model to have fine-tuning. So we'll look into it, like what it prints, and then you create a trainer. So this is how you're creating a trainer. This is you're specifying the training parameters. So if you look at the training parameters, so there is the training data set that we created, and there is the model that we passed, which we have LLAMA2. And then these are some of the hyperparameters that are being used. So there is not much now in the function, so we kind of do some manipulations, the data types before training, and then we start the training here. So the train function is called here. It just prints the metrics for you. So if you look at the output of this, you will see everything. And then you save the state, save the model, which obviously you want to save the state, save the model, and metrics, and you can. So this is how the training function is being called. So you specify the output directory and then train the model with these parameters. So all parameters are almost, how much is this? 3 billion, I think. Trainable parameters are 39 and trainable percent is 1.12. And then when you print these metrics, you can see that the training loss is decreasing as we go down. You can add more number of epochs, but the GPU instance might not be able to help you in that. So generally, like not this GPU instance, so you need probably a detailed one. To later load and use the model for inference, we have used the trainer model save pre-trained function, which saves the fine-tuned model weight, configuration, and tokenizer. So if you want to implement a new weight, or you can generate new weights, then you have to specify early stopping callback, which is a very transformer specific fine-tuning process. So you can, once we have our fine-tuned weights, we can build our fine-tuned model and save it to a new directory with its associated tokenizer. So you can load the pre-trained model that we talked about, auto-PEF model for casual LLM. So this is the fine-tuned model, and then we load this, and then we auto-merge directory, then we save the pre-trained model, and then this process continues, and that's how you have fine-tuned the model. So this is all the steps required to basically fine-tune your Llama